Okay, so we did 12.2 surface area of prisms and cylinders, and we did 12.3 surface area of pyramids and cones. And we're going to skip over 12.4 and 12.5, and I want to do the surface area of spheres. And we're not going to worry about doing surface area and volume, we're just doing surface area. So to visualize a sphere, I think we all know what a soccer ball or a ball would look like. And you have infinitely many congruent circles in space with the same point for their center. All right, and these circles form a sphere. So the sphere is the set of all points in space, so we're talking three-dimensionally, that are equidistant from a given point called the center. So just like we have a center of a circle, we have a center of a sphere. Now, when we take a plane and look at the intersection with a sphere, we basically have three options. We can have it just intersect at a point. Think of that kind of like a point of tangency. Picture if we slice through the circle, right? It's going to be just, a circle. It could be smaller if it's towards the edge, bigger if it's towards the middle. And what happens when it goes right through the middle? We have what's called a great circle. And yes, that's the term for it. A great circle is, if you kind of think of the equator, right? That divides into the northern and southern hemisphere, or the prime meridian, right? We think of those as great circles in terms of our Earth. So when we have a great circle, it divides it into two congruent halves. Called hemispheres. Okay. Note that a semicircle has a circular base, and actually that should say hemisphere. Hemisphere has a circular base, right? Okay, so here we're just going to jump right into the formula. Surface area of a sphere. The nice thing about surface area and volume for sphere, there's only one measurement that we need, and that is the radius. So the surface area is 4 pi r squared. So let's take a look, find the surface area of a sphere, round to the nearest hundredth. So our surface area is 4 pi times 5 squared. So that's going to be 25 times 4, so that's going to be 100 pi, which is 3.14159 or 16, and it's going to be square feet. Next one, we want surface area here, 4 pi. If this is 8 all the way across, this is going to be 4. So 4 squared is 16, times 4 is 64. 64 pi is 201.06. Okay, then we have example 3. So we want to find the surface area of the hemisphere. Now, we basically have to consider two parts. We have, think of this as like a bowl, but the bowl has a cover on it. All right, so we'll do the bowl part first. So we'll do this part going around the outside. Well, that's going to be 4 pi r squared, the sphere, but then we're going to divide that by 2. Then we need to consider the cover. So imagine we need to consider the cover on top, that flat part of the hemisphere, and that's going to be another pi r squared because that's another circular face. So if you think about it, we have 2 pi r squared for the bowl part, and then pi r squared for the other part. So every time we have a surface area of a hemisphere, it's going to be 3 pi r squared. So in this case, our radius is going to be 2, right? Half of 4. So we have 2 squared is 4 times 3 is 12. So 12 pi is 37.699. So that's going to be 70 and square feet.